Welcome everyone again to Snorkel Science Talks, a series where we interview AI thought leaders and discuss themes around making machine learning and AI in general practical. And today we are joined by Jason Fries, a research scientist at Stanford University with the Center for Biomedical Informatics Research. And Jason and I today will be talking about biomedical applications of Snorkel, how to empower doctors and scientists and ML with weak supervision, and how to utilize organizational resources in Snorkel applications. Jason, thanks so much for joining us.
Yes, thank you for having me. It's an exciting opportunity.
Absolutely. So we'll start off with some background, and in this case, it's a very long one. Jason and Snorkel go way back, arguably one of the very first contributors and users in real-world applications. So we'll cover that in more detail in a bit, but maybe just before that, Jason, we'd always love to hear people's basically path to ML and what eventually landed you to where you are now.
Yeah, I mean, it was definitely not a straight line. I originally in undergrad, my intention was to go into medicine, but I enjoyed my engineering classes way more than my biology classes, so I shifted. And then originally, my intention was to wrap up undergrad, which I got a computer science and English major, but my intention wasn't even to go into research, but I ended up working with a research group at the University of Iowa who were working on tracking infections in hospitals. And sort of I suddenly found myself helping like put sensors on healthcare workers to track their movement and then pulling a bunch of data from their hospital infrastructure to try to determine where they were, all for the purposes of sort of tracking and anticipating how diseases spread through the hospital. And I sort of was, really overwhelmed and excited by all of that data. And just my mind was blown on how you could even possibly try to make sense of it. And that's like the first time that sort of machine learning as sort of a concept and like a powerful paradigm really started to take root in sort of my imagination. And then after that, I was sold and went to grad school and slowly started working with EHR data and found myself doing, all the standard ML stuff to get there.
Great. Yeah, I think I say this every time, but it continues to be both a surprise and not a surprise at all how few people have what you'd consider a linear path to ML. Really, I think it's been this
Yeah.
collection from so many different disciplines over the years as we find that's the right tool for the job, in this big data world, and so many interesting ways that people have landed there. So,
Yeah,
let's hop right in with
totally.
your background with Snorkel then. Do you remember what the very first application was that you applied Snorkel to?
Yeah, I mean, this was actually so Alex was writing the data programming paper for NeurIPS, and sort of the very first introduction to even this as a concept was there was a hackathon we ran at a coffee shop called Hana House in Palo Alto, and we got a bunch of people together to sort of test writing some applications for like tagging disease names in text. And that turned out to be part of one of the experiments that went into that paper. And so that was my first sort of, my first introduction to the idea of generating training data without using hand labeled stuff. And it was sort of this complete crazy paradigm to me. I remember it just making zero sense in my initial sort of introduction to it. But yeah, but then after that, the hackathon started to be a regular process of the Snorkel development cycle. And I would, collaborate with, Alex and Stephen Bach and other folks like, Henry to sort of think about how you could actually make this work for a lot of real world problems and across a very large variety of spaces beyond even biomedicine, what my focus is. So yeah, and then that sort of was the kickoff to weak supervision, which I've been, quite sold and enamored with since those early days in the Hen House to solve all kinds of interesting real world problems.
Yeah, I mean the breadth of places where you've applied it, I think, is actually pretty astounding. I mean, just personally, I know of you've done MRIs, you've done medical health records, you've done device surveillance, a different type of document. I know there was some time series stuff in there as well. Has it been uh, more of a rinse and repeat process, or each time has there been some amount of learnings as you've pushed the boundaries a bit on the next application?
Yeah, it's very different by modality in my experience. I think text is the one that really benefits from a lot of the ecosystem of machine learning, from cool stuff like now Hugging Face, and just sort of a lot of even if we rewind the clock a few years, all of the existing stuff, Spacey and all of the effort to build all these sort of nice tools to work with text. It's very different with images or MRIs, or especially medical imaging, which is quite has its own challenges. But yeah, it requires really if you think about how to wrangle different sources of labels, it can be very challenging to sort of think about effective ways to make that work. And certainly, I think the text and to a little bit of imaging sort of are the most really benefit from what's been done, and are actually lots of progress can be made with sort of what's out there versus the real need to develop a lot of new methods. I think with like time series stuff, which we mentioned, we did a little work with basically sensors to detect freezing of gait in Parkinson's patients. That really benefited from sort of a very controlled setting and a lot of domain expertise. So that's the type of thing that's like a cool first step, but like more of a beginning down the road of how you might think about applying weak supervision there.
Yeah. One of the ideas that we've always found very exciting about the snorkel paradigm is the way that it empowers the do-gooders of the world to do more good, to be magnified a little bit, right? So a single doctor or scientist or journalist can now spin up a state-of-the-art sized data set and model without having maybe the much larger and more expensive organizational support that was once upon a time more required. In your experience, having worked with a lot of these doctors and journalists and scientists, how close would you say we are to that vision, and what's maybe left to get us the rest of the way there?
Yeah, that's an absolutely great question. I think it's pretty challenging. I think there's a clear sort of narrow band of application settings where a single individual or a small team of individuals can really make a lot of progress in like building a model using all kinds of really fancy stuff. And in the healthcare setting specifically, there are a lot of sort of logistical challenges to data and sort of other sort of barriers. So there's been lots of really awesome effort by like groups like the Odyssey Initiative out of Columbia, which is taking observational data found like in EHRs and sort of putting them into a common format so that people can build sort of ML models over them more easily. And those types of that sort of setting where you could specify some sort of model and then potentially deploy it on multiple hospitals that all have their data in the same format. That sort of scope of application, I think there's lots of awesome opportunity to plug into all the great stuff around auto-generating labels and denoising supervision sources, and then hooking your wagon to the kind of auto ML Ludwig stuff that makes just the guts of training a model much easier. I think in the general vision of where we'd like to be, in terms of like enabling, let's say, a frontline clinician or a scientist who has a particular question, there's still a lot of like road to travel. To be concrete about this, like a lot of like if you actually talk to doctors, especially people who actually see patients, they often need guidance on how to make clinical decisions, right? And they have intuitions or strong insights into things, but it's quite challenging to translate that into a formal problem by which you could imagine training a model over. And so in Nigam Shah, who I work in his lab, he has a big effort called the Green Button, and that sort of explored this idea of how can we marshal a bunch of data to sort of provide real world evidence on demand, more or less. And sort of that's a very compelling idea, but it requires like this huge effort across data and scientists to enable this pipeline to sort of answer, even like sort of simple guidance questions. I think the COVID-19 stuff has really highlighted how people really have immediate questions they'd like guidance on. If I send this patient home, on supplemental oxygen, are they going to come back in 30 days, or what's the likelihood that they're going to be readmitted for a problem? And these types of fog of war questions in the middle of clinical care are super important. And so how can we sort of build a machine learning infrastructure that enables asking these of the front line? And that's where a lot of work still needs to be done. I think specifically from this sort of idea of like AI DevOps or clinical DevOps, sort of how do you maintain and monitor and update machine learning systems in an infrastructure and institution? And so you have like your Googles and Apples have started making forays there, but hospitals are still, quite a bit behind in terms of having that infrastructure, or even, best practices to maintain that infrastructure in a clinical setting. So there's lots of sort of, questions to answer before we, sort of are more in our dream setting where, clinicians are more empowered to answer questions, fed by AI in the background.
Yeah, so it sounds like a lot of the technologies come a long way, but the packaging, the form factor, the maintenance, a lot of these ML ops, DevOps kind of components are, if not already, certainly going to be another bottleneck that needs to be tackled in some way to move forward and
Yeah,
really get this to frontline workers, as you said.
yeah,
Cool.
absolutely.
So in addition to the sort of cost or reduction in cost for person hours when it comes to making a new application, there's also this other axis, which is how well you're able to use existing work or work that and knowledge that's already encoded in various forms that may not be ready to feed directly into a machine learning model, but could otherwise be useful. Of course, this is something that we support and promote a lot with Snorkel is taking organizational resources and repurposing them. I know that you did some of the earliest experimentation that we had in the Snorkel project with converting ontologies into labeling functions, and in general, I think the medical field is very principled and structured in a lot of ways in the way they organize data. So that's in some ways a very good fit for considering these techniques. Could you tell us a little bit more about that and what your experience has been in terms of where that you have maybe the best fit of reusing some existing organization of knowledge to be repurposed and fed into machine learning?
Yeah, absolutely. I think, yeah, like concepts like ontologies and sort of concept graphs are part and parcel of medicine, which deals strongly in, canonical terminologies like SNOMED or medical codes like ICD-9, 10. And those are all the sort of standard way in which, information is communicated and exchanged potentially across hospitals and organizations. And so what sort of the easiest that I have discovered, certainly the most sort of readily available, is sort of concept or terminology classification. And a pretty common process is that you want to extract a bunch, say, in clinical notes. You want to tag a bunch of concepts, in structured data, and then sort of either bin them into broad categories or more finer grain categories. And so in that regard, these sort of structured knowledge representations are immensely useful. And the classic problem, if you talk to people about these sort of cathedral data artifacts like the unified medical language system, is everyone says they're super noisy, which is absolutely true if you want to reason over multiple ones. And so that's where something like Snorkel has been just very nicely suited, is this idea of sort of combining these signals in a way where you can reason about that noise and correct for it and get many of the benefits of hand labeling. And I think that that concepts are where I sort of have the most practical experience, but there's lots of things around classically hard problems like relation extraction or sort of link prediction across concepts that are immensely suited towards these sort of knowledge graph representations and pouring them into Snorkel to build stuff. And the last sort of nice bit is that ontologies are used. They are a canonical input into virtually every sort of clinical concept pipeline. And so, Snorkel can just sort of slide into a lot of these existing workflows and provide, often just a nice benefit with in some regards, a little change to how the actual process is done for, whatever infrastructure is in place already.
Excellent. And you've alluded to this a little bit, but the ability of Snorkel to not just create a training set, but to sort of be kept up to date or maintained is an important piece, really in any machine learning pipeline. And I know that one of your current research interests is dealing with these types of dynamic situations where you have rapidly changing data. So actually would love to hear if you could share some of your experience from the field within the biomedical domain. What are some of these types of problems where the data changes rapidly and you therefore need to be pretty on top of keeping a training set up to date?
Yeah, it is a challenging problem. COVID has revealed many of those exact settings. For example, just to give a concrete one we've actually done in text, when sort of the pandemic initially started, there was a lot of questions about sort of risk factors and how do we optimize testing for who needs to be tested for COVID, and it was unclear, what symptoms are necessarily strongly associated with COVID or discriminate COVID from other respiratory illnesses. There are lots of risk factors. So, do you live with someone who has been confirmed as a diagnosis? Have you recently traveled? And all of these are sort of things that don't necessarily show up prior in clinical notes. There's no sort of like setup to answer these questions easily. And so again, like it's a very nice sort of fit to Snorkel where literally in like a day or two, 2 or 3 people could go and look at a very small sample of notes and spit out enough rules that when you combine them, actually did a pretty good job of extracting this information. And so specifically for the symptom example, we worked with the Gates Foundation to actually run Snorkel real time or daily real time on all of the emergency department notes that were generated by Stanford to extract symptoms and basically look for summarize the state of what people were presenting within the emergency room. And that's actually that data is being used by Carnegie Mellon for various modeling purposes. And it's something that we needed to make changes sort of as we were learning stuff quickly. And you needed sort of a paradigm like weak supervision or Snorkel to sort of do the best job we could versus sort of taking off the shelf stuff, which you helped a little, but wasn't quite what we needed. And there are lots of, you can imagine lots of scenarios like that as things change, either due to crazy pandemics or, more subtle things like, practices change over time. And even, as we see more models being deployed in the hospital, models themselves induce changes in behavior. And so there may need to be changes that need to be baked into your training data, and lots of sort of interesting settings where we just need flexibility in sort of how we control what is fed to our model training procedure.
Yeah, so interesting. It sounds like there are both changes in the world environment and obviously a new disease pops up or new things that need to be tracked in that way, but also maybe just differing or changing needs in terms of what you want to track. You realize that certain properties that were not previously being requested or recorded now do need to be, but the training sets don't exist or the off-the-shelf models don't exist for that. And so that's a place where you need to fill in gaps.
Yep.
Makes a lot of sense. Cool. Well, thank you so much for joining us, Jason. Before we let you go, where can our listeners or watchers find you on the internet and your work?
Yeah, I have a Stanford website that I will post updates, including to this video podcast. And that's where sort of my recent work or recent things I'm participating in show up. And lots of weak supervision stuff as we highlighted at the top of the hour. So I'm happy to happy to be available to people with questions too. So
sounds great. We'll include those links with the video. So with that, we'll wrap up. Thank you, everyone, for joining us today. We'll be back soon with more discussion around making AI practical. See you then.